Welcome all to a 15-minute introduction to programming and Python. This is also going to serve as a recap for the first 3 weeks of Excode. This session is going to be divided into 3 main sections: a general introduction to programming, variables and data types, and data structures. First, what is a programming language? A language is used to communicate information between humans. A programming language is used to communicate information to a computer. This is often done in terms of instructions, meaning tasks that we ask our computer to do for us. The base unit of a programming language are lines of code. This is the simplest one, asking the computer to print something on the screen. We can translate that into display something on the screen. We can see here the interaction. Looking at the line of code and dissecting it, we often first have a line number, which is useful when we have complex software, meaning a lot of lines of code interacting together. Then we have an instruction. We ask the computer to print. To then display what we want to print, we use brackets and then the quotation marks. The quotation marks are there because we are saying to the computer to print text, as we're going to study later in this video. What is a computer program? In life, a program is a set of activities to achieve a specific goal. A computer program is a set of lines of code in order to achieve a specific task, a set of instruction to achieve a broader task. Often, we can divide programs into what comes in and what comes out and what happens inside of the program. Here, there is an example, converting a temperature from Celsius to Fahrenheit. What comes into input is the temperature in Celsius. We do some math, which is processing, so the computer is going to do that for us. Then the computer is going to print, so display on the screen, temperature in Fahrenheit. To get an input in Python, we use input, the bracket, and then ask some text with the quotation mark as a question. We use something called command line interaction, where when we say input, it's going to ask a question to the user, to the person running that program, which means giving the program to the computer, and then it can put some text as an answer, and the program is going to save that answer. Thinking like developers. We studied several key points of thinking like developers. The first one is called abstractions, which is when facing a problem, you can make abstraction of the useless to focus on what you really need. The second one is called decomposition, which means breaking down a complex problem into simpler, more manageable tasks. We also thought about how developers are a little bit the chef in the programming world, which means that they do not only focus about the actual code, but they also focus about the whole life cycle, which means getting to know the problem, then understanding what is the optimal, safest, and more error-proof way of solving their problems. When there are errors that will naturally arrive from any code, they also learn how to deal with those. We learned that there are 3 main things to look for: the type of the error. Errors can often be divided into main types, the line, so where the error is, and then finally the description. So the programming language is going to kind of explain to us the error. Often we need to use external sources to solve those errors. We can thus use Google, a website called Stack Overflow, ChatGPT, or ask other people to find a solution to our errors. Errors are normal. What makes the developers is the way you approach and are able to solve them. Week 2, variables. Variables are boxes in a computer, which means they are used to store information for us in a computer. There are 2 things, which are variable name and then value. Use an equal when creating one line of code. Variable name is equal to the variable value. This means that then later we can retry and get back to variable value. For instance, here, if I create a variable with the content hello world seen here, I can get it back by saying print variable name. We can see that there are no quotation marks on the variable name. This is because quotation marks are used to represent text, strings, while here variable name is a variable. And so the computer will understand, as there are no quotation marks, that this is a safe variables and go back to the text that is inside. As stated in the name, variables can vary, so change. We can update the value of a variable. We can put a new value inside of our box, and then when we try to retrieve it, we're going to get the new value. Data types. As boxes can have different items, we have different type of variables that represent the different type of data we want to store in our computer. The main ones are first, letters and words, which often are in Python represented as strings. Strings are sequence or lists of characters one after the other. We always in Python represent strings via quotation mark. If you see quotation mark, you think string. Then we have numbers. Numbers can be divided into integers, so whole numbers, and then float, fractional numbers. We use a dot to represent the fractional number. We also have Boolean. Boolean are extremely important what we're going to study in the following weeks, which means logical values to do all the logical and conditional and Boolean operations. These can be divided into either a state of being true or being false. Often this can also be represented by a 1 for true and a 0 for false. This is something that we're going to study later on. There is also a fourth and bit different type, which is nullable, so all the errors or non-existent data types. Null representing no value, meaning you have created a box, but the box is empty. And defined around declared represent that you have not created the box. So you are trying to get the box, but you have not created it. Then finally, there is also not a number, which means that you are trying to do impossible mathematical operations. There is something in Python called type that allows us to get the data type of any variable. It takes as input a variable to use type, parentheses, and then you put a variable name. Then Python does its thing, and then you get as an output the data type of that variable. This is useful if you want to check in your program what happens to all your variables, and is extremely important when we go on with more complexity to our programs. Type conversion. Type conversion is the process of changing data types. The more intuitive example is when we take an input. An input is going to be interpreted as a string, as some text by the computer, because it's a communication between command line interaction, as we told, between the computer and the human. We're asking a question and taking an input from the human. But then what happens if we want to do mathematical operation with that input? We have to convert it from some text to some integer. This is an example. If we take as input the temperature in Celsius, we're going to have to convert that from a string to an integer or to a float to then do some math on it. And then we can also convert it back again to a string to present it on the screen. To do so, we use something called string concatenation. The idea is if you put together multiple strings, you can display something. You can also, so you concatenate different strings or also variables. Concatenate means put together, and then you print them all in one simple formatted line. Is a table with a recap of the explicit data conversion, which means that we are asking the computer to convert data type. Some of those are possible, other will result in an error, and other will result in a data loss. For instance, every integer can be converted to string. So 42, any number can become some text. But not all strings can become an integer. The string 1 to 3 or similar strings can become an actual integer. But the string hello, the text hello, cannot become an integer. We can also have conversion between integers and floats. So all integers can become a float without problems, but floats will have a data loss when you convert those to an integer. For instance, 3.5, if you want to convert it, which is a float, if you want to convert it to an integer, so a whole number, it's going to either be 3 or 5. It cannot, so you're losing some data along the way. Then the third concept, data structure. We study how a variable is a box in a computer and allows us to store information. But then in a computer, you often want to work with a lot of variables, much more variables. So here we can introduce data structures. The simplest data structure is called a list. A list is simply a shelf of variables. So if we think about each variable as a box, it's simply a shelf where every box is put on top. Often, to make it simpler, and similarly to how a librarian will organize his library, we do not have a name for every single variable on our list, because this will make the list much more complex. What we do is we have an index that represents its position. In programming, we start counting from 0. So the first box on our shelf will have an index of 0. And then every box can have a value. And this value can be a different data types, can be different things. Like you can have different boxes with different things that are all arranged on a shelf. As an example, is a list called primes, with the values, which are the first 5 primes, and then the index, which is the position 0, 1, 2, 3. Here we can go on to code. So the idea is we always use square brackets to represent the list. In programming, you have different symbols to represent different type of concepts. Square brackets, you think lists. We also use commas to separate different items on our list. So here we can see we use primes, which is the name of the list. We use the equal sign to assign it to something. Still like a variable, but it's just more complex, where it's a structure. And then inside, square brackets represent the fact that we have multiple. Inside we have 2, 3, 5, 7, 11. Here is another example of a list called programmers. Programmers here is going to have 3 strings, 3 text, 3 boxes with some text, with 3 names of programmers. This is a general structure of a list. We have different items, separate them by a comma, use the square brackets to represent the list, and then that's how you create a list. We also have plenty of ways with working with lists. Often we don't know all of them by heart, but we use something more conceptual, which is a cheat sheet. So the idea of a cheat sheet is I look at it and then I found what are the different things or what I can do with a list. With a list, the simplest thing I can do is access an element. So what I do is access it via its index. And I use square brackets. So name, square brackets, and then the index. If I want the first element, its index is going to be 0. Programming, we start counting back from 0. So we do name, square brackets, 0, and I get the first element in my list. So for instance, here, if I say programmer, square brackets, 0, I will get Ada Lovelace. So print programmer 0, the programming language is going to print Ada Lovelace. Then I have some more advanced way of working with lists. I can add boxes. So I do .append to add one at the end, or .insert index and then the box I want to add one as a specific position. You can also remove a box, so remove it by index, remove it by the value. You can also change the values to say prime 0 is equal to something else. It's like taking the box, putting something different in there, and then leaving the box there, but changing what's inside of it. We can also do something which is called slicing, or negative indexing, which means taking boxes from the end, negative indexing, taking boxes from the start, like list, square brackets, and 0 is the first item. List, square brackets, -1 is the last item. Slicing is the process of taking from a start to an ending point. We can also do operations on word list, such as getting the length of a list, reversing it, or sorting it. With mathematical operations, they are also more advanced, such as taking the maximum, minimum number, or taking the sum. You can also add 2 lists together, which means continuing the shelf, so putting the 2 shelves one next to each other. Strings. We introduce strings as data types, simpler than data structures. It is true, but strings can also have a lot of properties shared with lists. The reason is that we introduced strings as a list of characters, so a sequence of characters. So it is similar to a list. Even if the comparison is not 100% true, we can take a lot of things we just learned from lists and apply those to a string. For instance, if I say username square brackets 0, I'm gonna have the L. Is also when I have a simpler, this also works when I have a simple list, as here I define, as we learned on how to define variables. We can also work with strings as you would work with lists, such as changing to characters, removing a character, adding a character. Some more advanced things that are only applicable to strings are uppercase, so turning the entire string uppercase, lowercase, capitalize, or some other things. As always, you can use cheat sheets or search on Google to find the operations we can do on those. We also have multidimensional list. The idea of multidimensional list is that we can go one step beyond. So list inside of different lists. So for instance, it's a shelf of shelves. In a library, this is more like how things would happen. To find the different items, we use an index both for the shelf and for the item. This means that I have the first shelf will have an index of 0, so it's the first list in my multi-dimensional list. It means my list has multiple dimensions. And then the first item is going to have always an index of 0. So if I want the first item here of my entire multi-dimensional list, is index going to be 0, the index of the shelf, and then 0, the index of the item on the shelf. If I want the last item, it's n, so the n list, n on the nth position on that list. For instance, here on the example, it could be the first item on the second shelf, which is 1, because it's a second shelf, comma, 0 is the first item on the second shelf. We can work on multidimensional list in the same way as you would work with simple list, but just you have to use the 2 different indexes. You can also change, like work with shelves on a multidimensional list, or work with lists. So invert to list, remove a list, add a list. Simple. You just extrapolate what we learn with list to a multidimensional list. This will go on with even more dimensions. The last concept of today is called dictionaries. Dictionaries work with something called pair key value storage. The simpler way to introduce that is talking about real-world dictionaries. The idea of a dictionary is that you have a word, so a key, and you associate it with a definition, the definition of that word. So there is a way of storing data which associate a key with a value. So a definition from a word with a definition. So the word is the key, the definition is the value. So if I have the word, I get the key, I can get the value, the definition. We can create those as we need, so putting with associating keys with values. Here as an example, if I want to store all the years where my programming language have been released, I have the key is a string with the name of the programming language, and the value is the date. Often keys are unique, while values can vary, can be the same. What we can do is we can work with dictionaries, so we can, once I have the key, I can get the value. When I have the value, I can get all the keys that have that specific value. I can update a value, I can update a key, I can add items to my dictionary, so add another pair, so I add another definition to my dictionary, for instance, in a real-world dictionary. So there are multiple ways of working with dictionaries. This is the end of this recap. This is enough for you to build the foundations for the next Excode sessions. What I would recommend is that if you understand these concepts, you have enough to go on the next session. You can also try and do it back the workshops. Programming is also a lot learned through hands-on. So try to do the exercises. If there are concepts that you still do not understand, you can either try to do the workshop and try to look at the lecture code. So you put the lecture code and the workshop code one next to each other. Otherwise, what you can do is search for specific videos that are going to introduce the specific concepts one-to-one. So the idea is, if you look at a 20 minutes video on the foundation of dictionary, for instance, you're going to be able to better understand that concept. Thank you for your time, and I'll see you all next week.